Alright, so now it's not boiling, but before when it was boiling, it's still cold. Alright? So how can it be both? Alright, so this might be a little bit confusing because a lot of times when we think of boiling, we think something has to be hot. But that's not necessarily true. Boiling simply means that a liquid is turning into a gas. It could be hot, it could be cold. And you saw that I put liquid in there. But as you can see, it's all boiled away, turned into a gas, so it's all gone. But you can't see a liquid gas all that well. So I can do another demonstration to prove to you that the liquid's turning into a gas. See here, I need a little bit more of my chemical here. Just so I'm going to put it into this bottle. And we have another real cool device that's good at collecting gas, known as a gas collector. Also known as a balloon. I'm just going to cap this off real quick.
Gas collector. That's a balloon.
So what's happening to the balloon? Yeah, the balloon's getting bigger, right? So explain to me, why is this balloon getting bigger? Alright, so there's a gas going inside the balloon. Where's the gas coming from? Yeah, from inside, from this liquid right here, right? This liquid is boiling, turning into a gas, and that gas is filling up this balloon. So since this liquid is boiling, raise your hand if you think this liquid is water. Alright, does anyone know the temperature at which water boils? It's more than 80. 180.
100.
Yeah, real close. 212 degrees Fahrenheit. Is it 212 degrees in this room right now?
No.
No, that'd be a little bit hot. So you know what? This liquid isn't water, something that boils at a lot colder temperature. Does anyone know where the coldest place on Earth is? Coldest place on Earth. Close, the South Pole. So the exact opposite. So the South Pole or Antarctica, and the coldest recorded temperature ever in Antarctica and in the world was 129 degrees below zero. This liquid is something called liquid nitrogen, and this boils at a temperature of 320 degrees below zero. So right now this liquid nitrogen is about 400 degrees colder than it is in this room right now. That's why I'm wearing all this protective gloves right now. And you know, this balloon's getting pretty big, so let me ask you a question. Which one takes up more space? A liquid, which is up to about here, or gas, like in this balloon? Yeah, a gaseous balloon. So since this balloon's getting pretty big, there's two things we can do with it. If you want to see this balloon pop, raise your hand. If you want to see this balloon fly, raise your hand. So we got a little bit more flyers. All right, so we're going to have a 5-second countdown and we're going to let this fly. 5, 4, 3, 2, 1. Alright, nice guy. But can you guys move off? Move off the carpet, off the carpet, off the carpet, off the carpet, carpet, off the carpet. Alright? And even though we were able to fill up that balloon pretty big, I still have a lot of our liquid nitrogen left over. And that's because liquid nitrogen takes up to 700 times more space when it turns from a liquid into a gas. And another way to look at it is if I put some of this liquid nitrogen into this container here, I'll try to cap this off.
Well,
right?
you can't.
It pretty much doesn't allow me to. Right? What's happening is that the liquid nitrogen is boiling, turning into a gas, taking up 700 times more space, and because it does that, it obviously pushes the cap off. But I think most of it boiled away, so I don't think it's going to pop anymore. But we use liquid nitrogen for a lot of things. We use it for flash freezing a lot of food products, like vegetables when it travels across the country to keep it fresh. But what I want to do with it right now is going to be a little bit different. What I want to do with it right now has to deal with this balloon right here.